Hello, everybody. All right, so what we're going to do today is we're actually going to start with a quick integer review, just to kind of get our brains back into mathematics after 8 weeks off of math. So we're just going to spend today on reviewing integers. So to start out, what we're going to do is we're going to just talk about adding integers. And I do that to give you guys to make sure that you have an in-depth understanding. We're going to start with algebra tiles. So let's say that we have a problem that looks like this, and we're going to keep it simple, all right? So just bear with the simplicity of this. So this problem right here is positive 4 plus positive 5. So what that means is I'm going to pull over positive 4 integers, and the green ones are positive. Then I'm going to pull over 5 more positive integers, okay? And so here are my positive 4 and positive 5. Okay, since if you look at this, they are all the same type. They're all positive integers. That means I can put them all together. Okay, so since I can put them all together, I just count them all up and I have a total of 9. I have a total of 9. So basically when you add two positive integers, you just put them all together. You group them all together and it gives you the answer. But let's say that our problem isn't positive, that it is both negative integers. Now, first of all, a lot of people ask, Mrs. Parkin, why are you putting a parenthesis around that right there, around the 5? Because I want you guys to understand that this is an addition sign. This right here is not a subtraction sign. It is a negative sign, and that's very, very different. So if I were to show you this with algebra tiles, or my fun little things here that I made, this right here would be negative 4, right? And then I'm going to add to it negative 5. So I got to add a couple more to that. So here is my negative 5. And again, okay, I don't have any zero pairs, what's called zero pairs. So to talk to you guys really fast about what a zero pair is. So if I have a negative 1 and a positive 1 like this is called a zero pair. Because if you were to put these together, basically what happens to them is they cancel each other out. They're gone, okay? Well, right here, there are no zero pairs. So basically, we just put them all together and we get a negative 9. Okay, so that's looking at how to add integers that are the same type, either both positive or both negative, okay, when you add them together. Okay, all right, so now let's take a look at a problem that we might use if we were using it on a number line, just to kind of show you another example. So if I had 1 plus 3, okay, so I always start at 0, and my first number is 1. So starting at 0, I go up to positive 1. Then I'm adding to it a positive 3 more. So 1, 2, 3 more, and I end up on positive 4. Okay, so this was my first jump. My first jump was a positive 1. Okay, my second jump was positive 3. I don't know why this is not turning colors. Was a positive 3, so it ends up on positive 4. So notice when I do this, I'm always going in the same direction because I'm adding two of the same positive integers. Now, what if I changed both of those and made them negative? So negative 1 plus, there's my parenthesis again, so you guys know that this sign right here is a negative sign, not a subtraction sign. But watch this. So I'm going to start at 0 and I'm going to go down to negative 1. So that represents my negative 1. Now I'm going to add to it negative 3. So I'm going to go negative 1, negative 2, negative 3. And I land on negative 4. So this represents negative 1. This represents negative 3, and notice I'm always going in the same direction, in the negative direction, because these are both negative numbers. Okay, so my answer would be a negative 4. Okay, all right, so kind of gives you a little background on why integers act the way they do when you're adding integers that have the same sign. So basically, the rule is this. When you add integers with the same sign, you add the numbers together and you give it whatever sign they both have. Okay? All right, so that's kind of a weird way of saying it, but so basically, if you look at these examples, right, 20 plus 15. All right, so I'm just going to add the numbers. Look at, they're both positive numbers, so I'm just going to add them together for 35. Since this is positive and this is positive, I know my answer is a positive 35. If I have negative 42 plus a negative 12, okay, first of all, I'm going to look. I'm adding. This is a negative, so I'm going to add 42 plus 12, which is 54. And then I look, oh, they're both negative, so my answer is a negative. So it's a negative 54. Okay, so that's what you do when you add integers that have the same sign. Now let's move on to adding integers with a different sign. So this would be like 4 plus negative 5. Okay, so let's look what that would look like with algebra tiles. So here's my positive 4. Okay, all right, here's my negative 5. Okay, all right, now this is what we talk about, zero pairs. See how these are two different colors? Because they're zero pairs. So these would match up and cancel out. All right, they zero themselves out. These would match up and zero themselves out. These would match up and zero themselves out. And these would match up and zero themselves out. So it leaves us with just one negative left over. All right, now, and I know some of you guys are like, oh, Mrs. Parkin, why are we doing this the long way? Because I want you guys to visually see what actually is happening, okay? Because really what's happening is this. We actually took the 4, and then we broke the negative 5 into negative 4 plus negative 1, okay? And then what happened was these zeroed out. They canceled out, leaving me with this left over, okay? On a number line, if I have 3 plus, well, let's go negative 3 plus positive 5. So if I'm doing that, the first thing I'm going to do, I'm always going to start at 0, and I'm going to go down to negative 3, which would land me right there. Now I'm adding positive 5. So what that means is that I'm not going to keep going into the negative side. I call it the dark side. I'm going to turn around and go positive, the happy side. So I'm going to go up 5 units. So this one is already 3 right there, right? Because I went down 3, now I go up 3. And then I have to go up 2 more for a total of 5. So this is a total of 5 right here. So that was a negative 3 down to there, up positive 5, so I land on a positive 2. So see how they go in different directions, okay? All right, they go in opposite directions. So let's take a look at a different example, okay? Oops, sorry. All right, let's try negative 4 plus 2. All right, so here we go. We're going to start at 0. Always like to start at 0. Okay, I go down to negative 4, which is right here. Then I'm going to, so that's negative 4 right there. Now I'm adding a positive 2. So I'm going to start at negative 4. I'm going to go up in this direction, 1, 2. All right, so that's a positive 2 right there. And I land on a negative. Okay, so that's how I use a number line to kind of help me figure out, you know, directions and stuff like that. But let's just get right down to the rule of adding integers. Because if you look at this, really I got negative 2 here. So, what did I do to my 2 integers? Well, I subtracted them. So here's the rule that and I want you guys just to start getting used to this. The rule for adding integers that have different signs. You actually are going to subtract. This is the real rule. Are you ready for this? This is like the right terminology. You are going to subtract their absolute values, okay? And you are going to give the sum the sign of the larger absolute value. All right, now, a lot of you guys are like, absolute value. I think I've forgotten what that means. Okay, so really quick, absolute value. Absolute value is basically the distance a number is away from 0. Okay, so if I have a number line, sorry, this is going to be kind of gross because I'm using my, my mouse to do this, so I apologize for the messiness. Okay, so if I ask you, and this is how you write absolute value of -2. Okay, it's kind of like the number goes in jail. So if you look at this, here's -2 right here. -2 is 2 units away from 0. So the absolute value of -2 is 2. All right, if I did the absolute value of 1, okay, 1 is 1 unit away from 0. So the absolute value of 1 is 1. Okay, so it's just the distance a number is away from 0. Okay, now I know that that is the correct terminology, but basically here's what you do. All right, when you have a problem that looks like this, -12 plus 20. All right, look at the problem. You can see right away that you're adding two numbers that have different signs. One's a negative and one's a positive. So basically, you're going to ignore the sign and you're going to subtract the two numbers from each other. Okay, it doesn't matter what order they come in, you're always going to subtract the larger from the smaller. So I'm going to go 20 minus 12, which is 8. Okay, so I know that my answer is going to be 8. All right, or close to 8. Then you got to give it the sign. You're going to give it the sign of the larger number. Okay, all right, so if you look at the two numbers that we have here, we have a 20 and we have a -12. 20 is bigger than 12 and 20 is positive, so my answer is a positive 8. That's it. That's all it's talking about. Okay, so again, let me go through that one more time for you guys, because I want you guys just to get used to the rule. Just know that when you're adding two numbers with different signs, okay, like this, okay, don't add them. You can't. Okay, and I know it sounds so weird, Mrs. Parkin. It's an addition problem. I get it. But the process that you use isn't addition, it's subtraction. So, excuse me. So we're going to subtract them. Okay, so 42 minus 24. 42 minus 24 comes out to be, sorry, just a second. Comes out to be 18. Then you give it the sign of larger number, right? Well, 42 is bigger than 24, and 42 is negative, so my answer has to be a -18. Okay, all right, so that kind of sums up adding integers. Now, with that being said, let's move on to subtracting integers, because guess what? You're not subtracting integers. Never, ever, 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 ever. Instead, you're going to keep, change. All right, remember? I don't know if I sang this song to you, but it's a popular song, backed by demand. Here it is. You're gonna keep, change. Keep, change, right? So you're gonna keep the first number the same. So don't touch the first number. But then you're going to change. So the subtraction into an addition sign. And then right after that, you're going to change the very, very, very next number into the opposite. Okay, so you're going to keep, change. So let's take a look at some examples. So we're going to KCC this. KCC. So we're going to keep the first number as a 4. We're going to change the subtraction to addition. And now 5 is positive, so we're going to make it a negative. And guess what? Now you're going to go back to the rules that you just learned about adding integers. Oh, wow, I have two different signs. So I'm going to subtract the two numbers from each other, and I'm going to give it the sign of the larger number. 5 is bigger than 4, and 5 is negative, so my answer is a -1. Okay, so same thing here. Ready? Keep the first number the same. So it's still a -4. Change subtraction to addition and make the second number into its opposite. Well, it was +5, now it's -5. And now we're going to go back to the rules of adding. Oh, I'm adding two negative numbers. So I'm just going to add 4 plus 5. Since they're both negative, I'm going to make them a negative 9. Okay, so look at this one. Ready? Okay. Oh, hold on. Let me see if I can get there. So keep the first number the same. Change subtraction to addition. And make the next number into the opposite. The opposite of negative 5 is positive 5. And then 4 plus 5 is 9. Okay? All right? And this is where a lot of people struggle. Once you guys change this subtraction problem into addition, this guy's gone, man. He's out of here. No longer do you have to look at him. Nope. Gone. You're now dealing with this. Got it? So let's do this one. Ready? Keep the first number the same, change subtraction to addition, and change the next number into its opposite. So it turns into a positive 5. Now, oh, look it, I'm adding two different signed numbers. So I don't add them, I'm going to subtract them. I know it's so confusing. Wait, I'm subtracting, I'm adding, subtracting. Just follow the process. So 5 minus 4 is 1. And then 5 is bigger than 4, and 5 is positive. So my answer's positive 1. So keep, change every single time. Keep, change. Okay? All right, so now, please, make sure that you guys do this every time you see subtraction. And the reason is because we're getting ready to solve problems, and you're going to get equations and just expressions that are going to look like this. 12 minus 2x plus 5b, now we better keep it simple, minus or plus 14 minus 12x minus 18 equals 20x minus 14 plus 8. I mean, something crazy like that. And if you just try to do this without changing it, chances are you're going to make a mistake somewhere along the line. But if you can change them all from subtraction to addition, it's just going to make it one step easier. All right, now moving on. Let's talk about multiplying integers. All right, well, let's just take a look at this because you know what? We've been doing this since like second grade, right? So 3 times 3, yeah, 3 times 3 is 9. Whoop, whoop, yeah. 3 times 2, 3 times 2 is 6. Oh, I see what's happening here. Okay, all right, these 3's are all staying the same, but these guys right here, looks like I'm going down by 1 every single time. So 3 times 1 is 3. 3 times 0 is 0. Now, I got to fill in the blank here. So what do you think if I continue my pattern? Negative 1 goes right in here, right? Well, now let's continue the pattern over here. From 9 to 6, I subtracted 3. From 6 to 3, I subtracted 3. From 3 to 0, I subtracted 3. So we got to continue, don't we? Heck to the yeah, we do. So we're going to continue our pattern by subtracting 3 every time. So therefore, okay, 3 times negative 3 has to be a negative, 3 times negative 1 has to be a negative 3. Well, let's continue our pattern. We're going to subtract 3 again. So 3 minus 3, it's going to have to be negative 6, right? Well, this would be continuing my pattern here. This is going to be negative 2. So 3 times negative 2 is a negative 6. Well, let's continue our pattern here. Okay, it was negative 2. Now it's a negative 3. So let's continue my pattern. 6 minus 3, or negative 6 minus 3 is a negative 9. Interesting. So take a look. So 3 times a positive 3 was a positive 9, but a 3 times a negative 3 was a negative 9. 3 times 2 is 6, positive 6. 3 times negative 2 is a negative 6. 3 times 1, positive 1, is a positive 3, but 3 times negative 1 is a negative 3. So basically, from this pattern, we can assume that when you multiply a positive times a positive, it's going to give you a positive result. And then a positive times a negative is going to be negative. Okay? All right, so let's look at this pattern here. So we already found out that a positive times a negative is a negative. So this has got to be, whoa, that's a big negative sign. Hold on, let me fix that. Okay, let's just do this. Okay, so this has got to be negative 9. Negative 3 times positive 2 has got to be a negative 6. A negative 3 times a positive 1 has to be a negative 3. So let's see the pattern that's happening here. Okay, or let's do this one first, because anything times 0 is 0. All right, so let's look at the pattern. So the pattern here, all of these are negative 3s. These are going down by 1 every time. So that must mean that this is going to be a negative 1. This is going to be a negative 2. And this is going to be a negative 3, right? Well, let's see the pattern happening here in my results. So negative 9 to negative 6, oh, we're adding 3. Negative 6 to negative 3, oh, we're adding 3 again. Negative 3 to 0, we're adding 3. So we got to continue our pattern, right? So 0 plus 3, so, oh my gosh, that's got to be 3 right here. 3 plus 3, this has got to be, this is a 2, by the way. Sorry, my 2 didn't come out very good. This has got to be a 6. And this has got to be a 9 if I continue my pattern, right? So we just learned something. We knew that a negative times a positive was a negative. But as we continued through this pattern, we saw that a negative times a negative actually ended up being a positive. Okay, based on this pattern. Well, let's just get right to the rule. Well, not quite. So here, another way to remember this is a slot machine. And if you've ever seen a slot machine before, it's basically, if you end up getting the same sign, you win. You're a winner. But anytime you have two different signs, you don't have the same sign come up, you're a loser. So ready? Here's the slot machine game. So I pull my slot machine and a positive pops up. Yay! All right, then I keep going. And this one keeps going. And another one positive comes up. So guess what? Did I win? Yes, I won. So since I won, I'm happy. And that's a positive result, right? So here we go. I pull the trigger again. Okay. Okay, a negative sign shows up. This one keeps going. Paching. Oh, yay, guess what? They're the same sign. So guess what? I won. Okay, because it's the same sign. So I'm a winner. Okay, so let's take a look at another example. Okay, all right, here we go. So, paching. All right, a negative sign shows up. Paching. Uh-oh. They're different signs, so I'm a big loser. Bummer. All right. Okay, so here we go. Positive sign shows up. Yay. Negative sign shows up. Boo. I lost. Okay. All right, and then the not very nice saying. My not very nice saying is this. When something good happens to somebody good, it's a good thing. Yay! When something bad happens to somebody good, it's a bad thing. Super sad. Right? Okay? When something bad, this is the mean one, don't repeat it, happens to somebody bad, it's like karma, it's a good thing, right? So, that's a not very nice saying, but it's a way to remember the rules of multiplying integers. So basically, to sum it up, when you multiply two numbers that have the same sign, okay, you get a positive result. So same sign gives you a positive product. Different sign gives you a negative result. All right, so a couple examples. Oh, did I put examples on the next page? Yes, I did. So ready? Okay, and basically, here's all you're going to do. you're just going to multiply the two numbers, and then you're going to go back and look at the sign. If the signs are the same, you get a positive product. If the signs are different, you're going to get a negative product. So ready? So 6 times negative 5. So 6 times 5 is 30. Okay, and then you go back. This is a positive, this is a negative. They're two different signs. You get a negative result. Okay, down here, ready? You're going to ignore the sign. 12 times 2 is 24. Now you're going to go back and look at the sign. A negative times a positive is a negative, so it's a negative 24. Okay, here we go. Ready? 3 times 5 is 15. And then you're going to go back and look. This is a negative and this is a negative, so it's a positive 15. Okay, look at this one. 7 times 3 is 21. Okay, and then this is negative and this is positive, so it's a negative 21. All right, so just some examples for you guys to look at. Well, good news. Dividing integers follows the exact same rules. So basically, you're just going to divide the numbers and you're going to go back and look at the signs. So if I had 10 divided by a negative 2, right? Well, 10 divided by 2 is 5. A positive divided by a negative is a negative. If I had negative 30 divided by negative 5, all right? We know that 30 divided by 5 is 6. A negative divided by a negative is a positive. All right, so here's what let's give yourself practice. So pause the video for a quick second, okay, and work through these problems. All right, and then we'll go back and check the answer. So give it a quick pause right now. All right, so you guys should have solved those problems, like on your desk or something. Okay, and here we go. We're just going to do this one. I'm adding two different sign numbers, so I'm really not going to add. I'm going to subtract 18 minus 12, which is 6. Okay, all right, and so then this becomes 18 minus 12 is 6. 18 is bigger than 12, and 18 is positive, so it's a positive 6. Okay, this one right here, oh, look at this. I'm going to keep, change, change. It's subtraction. Keep, change, change. Oh, yay! It turns into an addition problem with two positive integers. So it looks like I'm going to get 132. Okay, so my answer to this is 132. All right, this one right here, oh, I'm adding two of the same sign. They're both negative, so I'm just going to add 12 plus 66, which comes out to be 78. And they're both negative, so my answer is a negative 78. Okay, oh, subtraction problem, I'm not going to do that. I'm going to keep, change, change. All right, now I'm adding two integers with the same sign, so I'm just going to add the two together. So I get 135, and since they're both negative, my answer is a negative 135. Okay, this one, remember, there's several ways to show multiplication. Whenever you put a number next to another number but separated by parentheses, it's multiplication. So I'm multiplying these two. So I'm going to just multiply 20 times 4, which is 80. Then I'm going to go back and look at the sign. A negative times a positive is a negative. Okay, this one right here, 20 divided by 4 is 5, and a negative divided by a negative is a positive 5. Okay, so here's some examples. Hopefully you guys did well on them. So here's what you guys are doing today. You guys are doing a packet that's called The Case of the Invisible Illusionist. So read through the first page. It just gives you the information about it. Then you're going to get to clue number 1. So you're going to solve all of those problems. Make sure you show your work. If you need paper to show your work, I'm sure there's some paper laying around that you can use. And then you're going to go up and answer the clue. Okay, you're going to do that for clue 1, clue 2, clue 3, clue 4, and then clue 5. Okay, all right, they're all the operations that we just got done talking about. From those clues, they're going to give you information about possible cures. All right, and so you can use that. If you get stuck on the cure part, we can maybe we'll talk about that on Tuesday. All right, but for the most part, you guys are doing all of the pages on here in the packet. Okay, and then we'll start with how to answer the clues tomorrow. Okay, please be on your very best behavior.